Hello, everyone, and thank you for joining us today. We know you're very busy, and we appreciate you choosing to spend the next 30 to 45 minutes with us. In today's webinar, we will examine how to integrate real-time deep link graph analytics with Apache Spark AI. We hope you will enjoy this presentation and find it informative. My name is David Ronald. I'm the Director of Product Marketing here at TigerGraph, and I'll be your host. And I'm joined today by my very capable colleague, Emma Liu, who has a master's degree in engineering from MIT and a BS in engineering from Harvey Mudd College, prior leadership experience from Oracle and MarkLogic, and her areas of specialty here at TigerGraph include cloud, containers, enterprise infrastructure, monitoring, management, and connectors. And just before I pass control of the webinar over to Emma, I wanted to run through 3 quick housekeeping items. Your phones are muted, but we absolutely do want to hear from you. So please feel free to submit your questions at any time during the webinar. And you can do that by clicking on the Q&A button in the Zoom user interface. Secondly, the webinar is being recorded, and we'll upload it to our website shortly after the webinar concludes. That usually happens in 2 to 3 hours. So if you have to drop off or you want to share with your colleagues, or for whatever reason, you need to view the archive, it should be ready in the 2 to 3 hours. And we will also send you an email with the URL in that email. And finally, if you have any issues with Zoom, please contact the panelists via chat, and we'll do our best to resolve those issues. Okay, Emma, over to you.
Okay, now you can see the slides again. So this chart has the 7 key data science capabilities. And I want to start from the first one, which is the deep link and analysis. This means the ability to efficiently traverse a graph for 3 or more hops, and also analyze the data encountered in that traversal. And TigerGraph can easily traverse 10 or more hops. We have covered that in an earlier Graph Guru webinar, and you can look into the details. The more hops that you traverse, the more insight that you can enable from your data set. And the deep link analysis really powers the next generation fraud detection, anti-money laundering, and as well as the recommendation engine. And the next part is the multi-dimensional entity and pattern matching. And this capability really means if given the pattern, you can find a similar patterns in the graph. You can search for the graph for all the occurrences of the pattern that you first are provided. So a native parallel graph like TigerGraph can really find these kind of patterns really quickly, often in real time. And these are for the use cases that, for example, to find customers who are likely to churn or are ready to buy the next product or service. And also the members and patients who are suitable for a specific type of drug or products. The third one is the relational commonality, discovery, and computation. And this is really talking about given 2 entities. TigerGraph traverses their relationships to find the commonality and also the similarity between the 2. So just think about the use case that you want to find the common members or patients for a set of doctors, or finding a common customers for a set of merchants, or just finding the common business or personal connections among the group. And the fourth one is the hub and community detection. And this is talking about finding the most influential members for a group or an area, and also detect the community around them with TigerGraph. This is very useful to find the population that find the doctors who can promote and deliver a new drug with higher efficiency to the population that really needs it most. And you can also use this to find merchants who are driving the increasing share of the wallet for a specific population, or the citizens who really appear to be influencing a group of people involved in suspicious activities, for example. And the fifth and sixth dimensions are geo and temporal graph analysis. This is really talking about the two additional dimensions and add to the richness of the deep link analytics. And you can analyze the changes in entities and their relationships with respect to location, data, and over time. And this episode, we're going to focus mostly on the machine learning feature generation and explainable AI. And this is talking about, we are extracting the graph-based features to feed into the machine learning process. And let's talk about the specific aspect of power explainable AI with TigerGraph. So here, what we're talking about is in the history of computing, we've seen that there are a few the previous phases. The first phase, the procedure era, where we put rule-based program to predict output. And the second phase is we put data and answer into a machine learning process and come up with rules with many parameters. But the process and model itself can be a black box, and we don't really know how it really arrives to certain decisions. And one of the biggest obstacle for this type of machine learning process in black box is to have this adoption in space such as government or insurance companies or banking, where you really need to explain to your customers how you arrive to certain decisions. The black box machine learning and AI system is not going to be sufficient. In these kind of use cases, then explainable AI is really needed. And you can imagine a patient receives a claim that was rejected. And as the AI solution computed like a high probability of potential fraud based on the history of this patient, we really need a model that can explain how this patient's claim was rejected. And using graph, you can really use this to represent the data model and to explain using a easier interface. So graph-based features will first clearly shows how the AI machine learning solution arrived at a particular decision based on the combination of computed feature values. In addition, TigerGraph also offers Graph Studio. It is a very powerful GUI for visualizing and exploring and analyzing relationships to show how the features were computed. And TigerGraph's native parallel graph architecture also ensures that the explainable AI can be rolled out to all the users within the enterprise, as well as the external parties with the real-time visualization, exploration, and analytics of interconnected data. All right, so why Spark and TigerGraph? So Spark, we can see that in many enterprises, you're using Spark in your ETL process as well as your machine learning process. And we think it's a powerful combination, combining two MPP and distributed computing system. So let's look at the typical Spark and TigerGraph data pipeline. Normally, streaming data and static data sources import into Spark, and Spark can cleanse the data. That's step one, and feeding into TigerGraph. And within TigerGraph, using the algorithm and machine learning models, and also other graph algorithm, you can compute the real-time graph features for the machine learning model training. And these real-time graph features can feed back into the Spark infrastructure. And within Spark, you can train the model. And after the machine learning model is trained, this model can feed back into TigerGraph. And this is where you can combine the real-time streaming data and the machine learning model within TigerGraph to predict the graph analytics which then in the downstream feeding into the graph insights and graph applications and BI tool, as well as visualization tool. So summarizing what Spark and TigerGraph do in this workflow. First, in the TigerGraph, TigerGraph and Spark can both do the data preparation and integration. In specific, Graph is actually pretty good at also merging data sets for, say, entity resolution. These are for more advanced data preparation ETL process. And the next step, TigerGraph can actually do unsupervised machine learning using some of the algorithm, for example, community detection, similarity, clustering. So this is a natural choice. TigerGraph is a natural choice for some of the unsupervised learning approaches. The third aspect is the feature extraction. So this is where TigerGraph shines for extracting the graph-based features for supervised machine learning. Of course, you can also use Spark to do the regular feature extractions. And fourth aspect is the model training, machine learning training. Normally in the use cases that we're seeing, people use a Spark to do the machine learning model training. And the next part is you can use TigerGraph to really validate and apply the machine learning model. And the last part, you can use TigerGraph to visualize and explore the interconnected data. As I mentioned earlier, TigerGraph has the visual SDK. You can really use our tools to looking at the relationship and investigate the data. All right, let's go into the machine learning use cases with TigerGraph. This is, first of all, just some of the background. This use case is talking about the real-time phone-based fraud detection with one of customers, China Mobile. So phone-based fraud or robocalls is really a widespread problem in the world. Statistics shows that in 2017, there were about 18 billion robocalls in the US alone. And to complicate the sheer massive number, the new spam and fraud scheme is very agile. And the way that people really approach the phone's fraud really changes frequently. So therefore, a solution which really reacts to the new situations in real time is very crucial. And in China, this problem is quite prevalent as well. Our customer, China Mobile in Shandong province, used TigerGraph to resolve the issue. Currently, they have around 600 million subscribers within and outside of their network. And the network has 300 million calls per day. And at the peak hours, there's about 10,000 calls per second. And the scale of the problem really requires a high-performance real-time fraud detection solution to identify multiple types of phone-based fraud. So TigerGraph's real-time phone anti-fraud detection uses our graph-based machine learning and decision system. And we are a hybrid OLAP and OLTP solution. So we're really a hybrid transactional and analytical processing platform. On the graph database side, the solution stores 600 million phone numbers, and there are about 15 billion phone-to-phone call edges. We're kind of using the 2-month sliding window. What we have on the phone call edges is the time and duration attributes. And in real time, we have graph updates about 10,000 calls per second at peak. And for this solution, we developed 118 graph features per phone. On the graph analytics side, the real-time machine learning has this 118 graph features per call. And the model, we retrain the model periodically with about 2 million calls. And at real time, when a call comes in, the call recipient is able to see the alert if the machine learning system determines that the call is suspicious. And this system is actually in production since December 2016. So it's been in production almost for 3 years. So I want to mention a few of the examples of the graph features for this use case. And we mentioned that there were about 118 graph features, and I'm just going to dive into a few of them here. Let's just look at how TigerGraph identifies features by really analyzing the relationship among the phones to see whether it's a good phone or a bad phone. And this is a phone, customer with a good phone calls usually will call other stable group, other phone calls, like here in the brown circle. There's a phone 7, 8, 9, and 10. We call this as a stable group. This means phone 1, which is the customer, will reach out to phone 7, 8, 9, and 10, and these phones will also call back. This usually represents a stable relationship, and normally these are the phones that is in your contact list. And a bad phone, which is not a stable phone, would not have this stable group, so it will be an empty stable group. And a second graph feature we call is the many in-group connections. This is the green circle that we're looking at on a good phone. For phone 5, 6, and 4, phone 1 calls them, and they are actually also a group of friends that contacts that would call each other. So this is pretty normal that if you have a group of friends or colleagues, you would regularly reach out, and they actually have internal connections as well. So we call this many in-group connections. And here, this is a very typical graph features because you're looking at multiple hop relationships. And for phone 4, relationship with phone 1 and phone 4, this is a long-term phone. This is a very common feature that for example, if you have a relative or your parents, you have a long-term relationship with this phone number, and you might only call them every week or every month. That's another feature that you can be looking at among the phone calls. So I'm just going to explain these 3 features here. We also had a previous Graph Guru webinar that actually talks about the specific use case in detail as well. Now, let's look at the workflow for this use case. When a real-time call event happens with the caller callee time information, it will go into the query into the, our TigerGraph database, and it will output a fraud type. And this fraud type is, in each of the phone node has a fraud flag and indicating it's a good phone or a bad phone, and also what type of fraud. And this process, if there is a fraud flag that already has the indication, you can automatically output into the phone system that, okay, it is a fraud call. If the fraud type is not determined yet, at real time, it will be determined through the machine learning model and the graph features that collected. And after each of the real-time call, this information will go into the call detail records with more of the information, and it will also update the graph continuously. And again, when we run the real-time GSQL query for each of the call, at the same time, we collect the 118 graph features, and we also compute the composite score at the same time and update the fraud flag and return a fraud type. So all these things are done in the same time in one GSQL query in real time. Now let's look at the graph model here, graph schema. So this is actually a pretty straightforward schema. When we're looking at the call detail records, it is the all call history of all the phones, and it can be represented as a graph model with phone as a vertex and phone-to-phone relationship as edge connecting the different vertices. And we did not build the edge to record all the call events because they're total about 600 million vertices and 300 million daily updates on the call events. It is not really possible to record all these events. So we actually aggregated these attributes on the phone edge to record all the call history between the two phones. And on each of the vertex, we also added a flag to record the identified fraud type of that phone and also the expiration for that flag. All our fraud detection features are built from these are the raw features as well as the graph topology information. So let's look at a workflow for the fraud detection query again. So in the case one, when the call type was recently flagged, if you look at all the blue squares and the workflows, when the real-time call event happens, the query into the TigerGraph, and then if it's already recently flagged, and it will show up on the phone that it's a fraud phone. In the case two, if this call still needs to be classified, it will go through the real-time collecting the caller's graph features and go into the classifier and classify the caller as bad and show up on your mobile phone that it's a fraud call. And of course, at the same time, we'll also update the graph database. So for the input, again, it's a list of calls with the phone pairs and also the call time. We're actually doing this in batches to be more efficient. And the output, first is the call fraud type. The second is the scoring and also the feature vector of fraud calls. And the second part was actually requested by our customers, China Mobile. Originally, we did not include the scoring and feature vector. However, China Mobile was asking, oh, how did you actually come up with to the conclusion that some of the call is fraud or not? They really need more of the supporting evidence from the machine learning model. So this actually really coincides with explainable AI that I mentioned before. Most of the customers are not satisfied with only a black box machine learning model anymore. They really need more of the evidence to help them to explain to their users and customers about the decision that they made. All right, just summarize the China Mobile machine learning use case workflow. First of all, all the data labels, which I didn't mention before, these labels are coming from the police reports and also some of the online third-party sources. And a total of 118 graph features were analyzed to build fraud detection model. And this is actually collected by one GSQL query. And the training data's feature are collected in GSQL, and it's in batch processing. And we store it as CSV file for future machine learning model training. Again, we actually retrain the model periodically, depending on the customer's needs. And then TigerGraph performs the real-time scoring. We actually use the multiple machine learning models, and this is performed in the real time for the fraud scoring and prediction. And the last part, machine learning models actually are trained offline, and the model parameters are stored as configuration files for GSQL for the real-time scoring. And in the future, we'll be trying to train machine learning models in Spark. Just high level, what are the benefits for doing machine learning with TigerGraph? First of all, we can really do the real-time scoring with multiple machine learning models with GSQL. GSQL is very expressive, and it's very fast, and we can provide the real-time response for both the feature collection and also the feature scoring. And it's also very efficient, meaning in TigerGraph, you can aggregate during the graph traversal. And you can do multiple features in one GSQL query. And it's very easy because you can collect very complex graph features without multiple RDBMS joins. Just think about if you want to collect these features in relational, you might need multiple joins, and it's not going to have the real-time graph feature, this type of SLA. All right, I want to talk about the benefits that our customer received from this use case. China Mobile in Shandong province, for the 2-3 years that's in production, we detected 3.2 million fraud notifications for this province alone. And the police department really estimated that we helped the local citizens to kind of save potential loss of about $6 million US. That's pretty substantial for this one province, that only through the detection system that we implemented for them. Okay, let's go back to why we're using Spark and TigerGraph together. As I mentioned before, Spark and TigerGraph are both built on the MPP architecture, and it's using the parallel processing, and both are distributed. And this helps in both of the model training, ETL process, as well as the feature collections. So it's a very good combination when you want to add graph and machine learning together. And TigerGraph really enriches Spark in the machine learning process with the complex graph features. Because of this performance, you can really capture a lot of business moments with the real-time response with actually explainable AI, right? I mentioned explainable AI before, that you can really talk about your model and talk about your prediction and decision-making using the explainable interface. And everything is done at scale. So when you use TigerGraph and Spark together, you can really deal with large data sets all together at scale. Okay, how do we actually facilitate the data flow between Spark and TigerGraph? So in 2.3 and 2.4 of TigerGraph release, we introduced the JDBC Driver for TigerGraph. And this is the way that we can facilitate the bidirectional data flow between Spark and TigerGraph. You can install the TigerGraph JDBC driver in your Spark cluster, and that will read and write from TigerGraph. Just a little bit more details on the JDBC driver. Currently, it's at version 1.2. It is a type 4 driver, and it supports the read and write bidirectional data flow to TigerGraph. During read, it converts the result set to data frame. And during write process, it will load the data frame and also files to vertex and edges in TigerGraph. And currently we support in TigerGraph the built-in, compiled, and interpreted GSQL queries, the REST endpoints for these. And it's currently an open source project, so you can look at that in our open source repository, and you can also submit pull request through this repo. Now I'm going to going to the demo to really use the TigerGraph's JDBC driver to do the graph feature extraction. Again, we mentioned that there are a few of the graph features that I introduced in this use case. In this demo, you will see we are looking at extracting the stable group and also stable in-group connections for this small data set. So for the demo purpose, we actually developed a smaller data set to demonstrate this graph feature extraction process. And to define what is a stable connection. Stable connection is actually for the connections that has both call and callback numbers. And for the number of calls is larger than a given limit. And also the total duration of the call is larger than a given limit. You will see those in the parameters that we input in the GSQL query. All right, let me stop sharing my slide. I'm going into the demo environment. Okay, let's see. I think I actually need to exit the presentation mode here. First of all, I want to, so the demo is actually done on Azure Databricks and TigerGraph Cloud. So it is connecting two of the cloud environments. So it's actually pretty convenient. Currently, I'm at the Microsoft Azure Databricks. I just want to make sure the cluster for the Databricks Spark cluster is up, which is true. Let's go to the TigerGraph Cloud portal. So for this specific China mobile machine learning use case, we actually already have a starter kits in our TigerGraph Cloud portal, which you can just spin up very quick and reproduce everything that I'm doing here within a few few minutes. Okay, let me go through a process of how you can use the starter kit to get to this demo specifically. So when you get to the TigerGraph Cloud interface, you can go to My Solutions, and here, click on adding a new solution. The first step, select a starter kit here. There's the machine learning and real-time fraud detection. Choose this starter kit. And I'm going to name my machine learning demo. And you can leave the tag here, machine learning and real-time fraud detection. I'm going to use a relatively small machine to do this, but you have 8 different choices that you can choose for the instance type. Then I'm going to select a AWS region. I'll choose the US East 1 here. Disk size, 100 gig is enough for this specific demo. For the subdomain, I'm going to say ML demo, test, machine learning, China mobile case. Now you can create the solution. And usually it will take a couple of minutes here. And after that, you can come to your solution dashboard and access the starter kits from here. So before the webinar, I already started another machine learning use case starter kits. So let's just use that. You can see all the IP instance types, region, and subnet VPC information. But here, you can connect to your solution via this button. And I already loaded the data here. So for this starter kits, we already pre-packaged the sample data there, as well as the sample queries. So for you, when you start this, you just need to load the data here and also going to the right queries page and also install the queries on this specific step. Let's just look at what this specific queries tells you, helps you to do. Actually, let me maximize this specific GSQL query. I'm not going to go into the details of all the commands and stuff, but from the big picture, you can see that we have two big blocks that enables the connections among the target group, as well as the collect its target group. So, and one of the clause that GSQL has is the cum clause. That's different from maybe the normal select from that you're used to in the SQL command lines. All right, now let's go to run queries. Let's see, choose phone 1. And I'm going to choose the duration time as 60 seconds. And number of call is 6 calls. Let's run the query here. Okay, so this is actually the result for the number 1. Let's expand the specific queries. And if we look at a different view here, visualize the graph feature, you can see that there is a in-group connection here between 9, 10, and 8. And there's also 2, 4, 6, 5, 3, which has just a regular kind of connection. So this is from the TigerGraph cloud side that I demonstrated this machine learning graph feature query here. And how does that actually go into Spark, right? Let me go to the Azure Databricks. So when you get to the Azure Databricks, you need to install the TigerGraph's JDBC Driver. So how you do that is going to the clusters, going to this specific cluster, and in the libraries, you can choose to install new JDBC Driver. So you can really just drag and drop the jar file for this JDBC Driver and install it. I already installed here before the webinar. And how you can get to the jar file, this is the ETL repository from TigerGraph, and you can make the jar file from this repository. All right, let's just go back to the workspace that I was working on at Azure Databricks. Let's change this number. This is a common standard process that you connect to the JDBC driver. This is the TigerGraph JDBC driver and the URL, which is from my TigerGraph cloud URL, and the user password for accessing the TigerGraph cloud solution. And you need to specify the graph name for the specific use case. And now we're just looking at choosing, the phone vertex. I'm going to choose 8 phone vertex, and let's see, let's run the cell. Normally, the first time when it's run, after a while, it will take a few of the seconds to warm up the Databricks Azure Spark cluster. So it's executing in the back end. Normally, I will change the password here, but the default password is TigerGraph, and you can change the password in the TigerGraph Cloud Portal. When you connect to, let's go to the admin portal for the specific use case, you can change the password here so that it's more secure. But this is for a demo purpose. All right. It should be there pretty soon. Okay. All right, now actually just, it took a while for the cluster to warm up, but once it's warmed up and submitted to Spark, you can see that it was actually pretty fast. That here are the 8 vertex that I chose, and all the flags now is 0. All right, let's go to the next connection. Again, you input all the driver, URL, user password, username and password for accessing TigerGraph. And we're currently looking at querying a compiled query because we already compiled and installed in our TigerGraph Cloud starter kit. And so this is the feature collection and phone 1, and duration limit is 60, and number of limits is 6, which is the same as what I demonstrated in TigerGraph Cloud. Let's just run this command again. And it's sending to cluster. Okay. So, okay, it finished pretty fast because the cluster, the Databricks cluster is already warmed up. And you can see that there are, for 8, 9, and 10, so these are the phone ID, there's 3 InGroup stable connection, which is the same as what we visualized in TigerGraph starter kits. For 8, the unstable connection is 9 and 10. For 9, it's 8 and 10, and for 10, it's 8 and 9. So we successfully queried the information and transformed into the data frames in Spark. All right, so this is end of my demo. Let's go back to our slides. So some more resources. If you want to replicate the entire demo, first register at TigerGraph Cloud, tgcloud.us, and you can use the machine learning starter kits, and everything, all the data and queries are already there. You just need to load and install. And then after that, you can get to the JDBC Driver open source repository for TigerGraph and make the jar file and upload into your Spark cluster, and you can communicate between Spark and TigerGraph that way. And this is how you can do a simple graph feature extraction between Spark and TigerGraph. Hope you enjoyed the demo. All right, let's just go back to what we talked at the very beginning from this Gartner code. Graph analysis is possibly the most effective competitive differentiator for organizations for the data workflow. But what I want to mention is for your machine learning data flow, you really need to think about the real-time deep link graph analytics at scale. And this is going to make a difference to your machine learning pipeline. Don't limit yourself to just the regular graph features, but consider all the graph features. All right, thank you for your time. And now it's the Q&A time. Any questions?
Thank you, Emma. That was fantastic. Very thorough.
Okay.
So we have a few questions from the audience. First question is, can you please list some of the 118 machine learning features that Emma talked about in her presentation? However, since China Mobile is a proprietary use case, we can't share the full list with you, but Emma did include a few queries or features rather in our presentation. And then the follow-up question was, can we see the GSQL queries that collected these features? And they'll be available on GitHub. I will send that link out after the webinar.
Yeah, not only that it's available on GitHub, it's already on the starter kits. As I said, it's already prepackaged in the starter kit. So you can just install and start the starter kits and then install, and you can see what the queries are. Yeah.
Okay, great. Thanks. A couple more questions from the audience. Emma, maybe you'll understand this question. Is machine learning model trained in TigerGraph in this use case?
No, in this use case, machine learning model is not trained in TigerGraph. But we've also just covered another use case about 3 weeks ago, Graph Guru, that we did a neural network training, model training. Yeah. Okay.
Great, thanks. Another question. How do I install the JDBC jar file?
So as I mentioned before, when you get to the Azure Databricks, you can go to the libraries and install the jar file there. So that's the easiest for this specific demo.
Okay, great. Well, thank you. I think given the time constraints, we'll move on. And if there are any other questions from the audience, we'll reach out to people individually once we wrap up. So thanks again, Emma. That was a very, very thorough, awesome presentation. So hopefully we've demonstrated, hopefully Emma has demonstrated that TigerGraph is very versatile. And we encourage you to try it for yourself if you're not already doing so. And here are just a few of the resources we have available to help you get started. And I would draw your attention especially to the first one on the list, TigerGraph Cloud. It's free to get started. And you can get going in just a few minutes. And we provide a free tier, a tier that's free in perpetuity for you. The only constraint there being as a single solution. If you wanted to have multiple solutions running, then we give you a $25 credit. And after that, we'll charge your credit card. But I think you will agree that it's a good way to get started to test TigerGraph with minimal obstacles to getting up and running. And just a couple more slides before we finish up. I know we're almost out of time. We do an in-person version of these Graph Gurus webinars, which we call Graph Gurus Comes to You. I think that's a good name. Sadly, I can't claim that I came up with the name myself. It was one of my colleagues. We've already done some of these events in different cities in the US. Over the past couple of months. We have events coming up in San Diego later this month, also in Columbus, Ohio, and in Boston, possibly New York City. And if you would like an event, if you'd like us to come to your city, please reach out to us, and you can do that at the URL that's shown in the lower left there, tigergraph.com/graphgurusrequest. And that brings us to the end of our webinar. We know that you are very busy. We know you had many choices of how you could have spent the past 45 or 50 minutes with us, and we're flattered that you've chosen to spend it with us. And I'm very happy that most people have stayed around to the very end. And I think that's testimony to Emma's very good presentation and demo. We hope you found the webinar informative, and we hope our enthusiasm for TigerGraph has been contagious. We hold these webinars weekly, usually at the same time every Wednesday, 11 o'clock West Coast time, 2 p.m. Eastern. We invite you to keep an eye open on our webpage for upcoming Graph Gurus webinars. And with that, we'll end here. I'd like to thank you again for attending. I know you're very busy, and I hope you found this to be an informative use of a productive use of your time. Thank you.